In this example, we're going to be looking at a double integral over a general region, and we're going to be looking at a quadrilateral, and this is our integrand, and it's going to be over the first quadrant bounded by the lines y equals x, y equals 2x, and the x variable is gonna go from x equals 1 to 2. Okay, and this is our integral, or double integral. We want to evaluate, and based on Fubini's theorem, we can choose to either integrate this first with respect to x or y, but we're going to choose to integrate this first with respect to x, and our limits that correspond to this integrand are the ones closest to our integrand, and the limits outer correspond to our y variable. So let's go ahead and integrate this out and see what this is going to look like. Okay, so we're going to choose to integrate our x variable first. So we're going to be holding y constant, and here y is going to be a constant, and our x is going to be integrated to x squared over 2. Evaluated at x equals 2, and lower limit's going to be x equals 1 times our differential dy. Okay, so let's plug in these values. So x squared is going to be 4 divided by 2, that's a 2, minus, and a 1 squared is 1 over 2, so that's 1/2 times the differential dy. And we get, it's going to be a 3/2 right here. It's a constant, so that can come out of our integral. There's the 2x here. And we got 1 over y dy. And we know how to integrate this. This is just the natural log. So we get 3/2 times the natural log evaluated at 2x, the upper limit, and x, the lower limit. And this is going to give us 3/2 natural log of 2x minus the natural log of x. And if we remember our rules of logs, the natural log of m minus the natural log of n is the natural log of m over n. And we can see that based on the law of logs, that these x's are going to cancel out. So this is going to give us 3/2 times the natural log of 2x over x, and this x is going to cancel here, the denominator and the numerator. So we're going to get 3/2 times the natural log of 2. So this is what our integral looks like after we evaluate it. Thank you for watching, and please subscribe.